All right, so here's your video for your Unit 10 quiz. These first ones, it says find the sum of the geometric series, and we are going to simplify all the way. So in order to be able to get a sum, it has to converge, which the absolute value of r has to be smaller than 1. But I'm telling you to find the sum for each of these, so you don't really have to worry about it. They are going to converge. I can't ask you to find the sum unless they converge. So for something like this, I would list out the first few terms. We're going to start with n being 1. So if n is 1, take 2, our first term is going to be -3. And then if n is 2, this is going to be 6/4, which would be 3/2. And then if n is 3, that's going to be -8. So -6/8 would be -3/4, and so on. Usually if you have 3 or sometimes 4, if you need a fourth term, then usually you're good. We need a, which is the first term, and we need r, which is what we are multiplying by each time. So it looks like for this one, we are multiplying by -1/2. And then your sum is a over 1 minus r. So -3 over 1 minus -1/2. So that'll be +1/2. And we are going to simplify it all the way. So like pretend it's multiple choice. Your choices aren't going to look like this. This would be 3/2. And when you divide by a fraction, that's the same as multiplying by the reciprocal. The 3's cancel, and you get -2. All right, this one is written in this nice format. I can see that our first term is 4, and our ratio is 2/3. So 4 over 1 minus 2/3. That's going to be 4 over 1/3. 4 times 3, so 12. All right, this one again, I'm going to list out the first couple of terms just so that I can kind of see what's going on. So if I plug in 0, anything to the 0 power is 1. If I plug in 1, I'm going to just get 1 over e squared. If I plug in 2, 1 squared is still just 1. E squared squared is going to be e to the 4th. And I think it can see it well enough there, so I don't need another term. So a is 1, and we are multiplying by 1 over e squared each time. The numerator stays 1, and then denominator multiplying by e squared. Sometimes I look at the numerator separately from the denominator, and that helps. So it is a over 1 minus r. I'm going to erase this 1 and write it as e squared over e squared. 1 is anything over itself. This way I have a common denominator here. And so this is going to be e squared minus 1 over my common denominator. And basically I'm just going to reciprocate that. So e squared over e squared minus 1. All right, these next ones, does the series converge or diverge, and give a reason? So we're going to have to think about all of the things that we know so far. So for this first one, I would do limit as n goes to infinity for this. My numerator power is bigger than my denominator power, so this is going to go to infinity. And so that diverges by our nth term test. This one I can see is geometric, following that pattern. This is A and this is R. Absolute value of R needs to be smaller than 1 in order for it to converge. So this is going to diverge. So it diverges because it's geometric, and the absolute value of R is 5/3, which is greater than or equal to 1. All right, this one is telescoping. So we're going to do limit as n goes to infinity for this second part of it. And if n gets bigger and bigger and bigger and bigger in the denominator, this is going to go to 0. And since that's finite, it converges. So it converges because it's telescoping, and the limit is finite. All right, and then last one, we are going to do an integral test for this. So I rewrote it with x instead of n. And we're going to do limit as b goes to infinity, integral 1 to b. So I'm going to keep my limit here. I'm going to need to do a u substitution. You can write it out if you want to, but u is going to equal this part. We're going to need a 1/3 as our adjustment number, and then there's a 2 already there. So normally I would just stick a 1/3 out front, but we have a 2 already there. So I'm going to put 2/3, and then it would be u to the -2 in the denominator, so it is negative. So I did a u substitution. I just didn't write out all of the steps. You, of course, can if you want. It's just you need a 1/3 adjustment number for the 3 that is there. So now we're going to do our antiderivative. We're going to add 1 to the power. Here, I'll write it off to the side. So if you add 1, it becomes a little bit less negative, and then you need to divide by a -1. So that is going to be -1 over u. I'm going to keep my 2/3 in there. So I've got my negative, my 2/3, and then u goes in the denominator, and that was our 3x plus 1. All right, now we're going to do upper minus lower. So if I plug in b, it's just going to be that exact same thing except with b there. And then if I plug in 1, what is that going to be? 3 times 4? Did I do that right? Yeah. All right, and then the last thing we're going to do is evaluate the limit. So as b goes to infinity, this denominator is going to get bigger and bigger and bigger and bigger. So this portion goes to 0. Negatives cancel, and that is 2/12, which is 1/6. So 1/6 is our answer to the whole thing. And so this converges by the integral test. And it's important to remember this is not what the series converges to. It's just that we got an answer. We got a finite number. If we evaluated this limit and this went to infinity, then we would say diverges by the integral test.